Dawson's going to go next.
Are you on this one, Rich?
Yes, no, I think it's.
Are you on
I think
this
it's
one?
this one here. Yeah,
Oh, right,
somewhere
okay.
in
Very
around. Yeah.
Very good. Right.
Great. Okay, as you will have gathered from Mike, he was very central to this project as well, although probably what I'm showing here is bringing together a couple of initiatives that were really started through the Tyndall Centre for Climate Change Research, which was funded through the National Research Councils to look at issues of adaptation to climate risks and mitigation, so reduction of greenhouse gas emissions. And really what we went about was development of an integrated assessment tool to look at a number of different trade-offs, perhaps between land use planning policy, but also climate risks and other issues. And the case study, again, was in London. And so the context was really that the world is changing and our cities and infrastructure need to try and respond to a whole host of these drivers, whether they are growing populations, changing demographics, aging populations, or perhaps changes in the way our infrastructure is owned and governed. Much of the infrastructure in this country is now owned out of Hong Kong and Australia and Germany. And one of the reasons for focusing in on the cities is, of course, this concentrates a lot of these issues and infrastructure. And, of course, in London, where we have several hundred-year-old pieces of infrastructure, there are a whole host of other challenges underneath us as well. And one of the things that soon became obvious is that a whole host of well-meant sustainability initiatives seem to have some potential negative effect. We think about cooling ourselves to reduce heat stress, but of course this has implications for energy and greenhouse gas emissions. Bypasses can perhaps take traffic out of city centres, improving local air quality there, but can increase congestion and journey times and consequently greenhouse gas emissions overall. And so there's a whole host of these well-meant initiatives people have put into place, but they often have unforeseen or unthought about consequences and impacts. And so part of the motivation for constructing this integrated assessment was to really provide a platform to unpick some of these, certainly not all of the ones that are listed on that table above, but with an emphasis on the climate and weather-related issues. And so as Mike introduced in his talk, we started off by looking outside the city, looking at wider pictures of socio-economic change, recognising that what goes on in however we choose to define London or the southeast or whatever is of course strongly influenced by external drivers, be they socio-economic or climate and so on. We then, as Mike mentioned, working with Cambridge Econometrics, looked at a range of local, so regional, London-based economic scenarios. How might that change in the future? And then this land use transport model starts to turn these aspatial scenarios into something on the ground, how employment, land use, population might change as a result of policy or infrastructure development. And this is where it gets a bit more interesting, because we can start to integrate these changes in land use with changes in climate risks or indeed and explore different adaptation strategies to manage those changes and risks, but also looking at implications in terms of greenhouse gases and energy and so on. And I'm not going to talk too much about that today because there's a whole host of stuff that we could pick up on in this project. But as was picked up just now, this work was done in conjunction with a whole host of stakeholders, Environment Agency, Thames Water, who are responsible for water resources, Transport for London. Many of you will have got here on one of their services over the last 24 hours. And, of course, the Greater London Authority, who are the administrative body for the Greater London area, as well as the central government agencies Mike mentioned, like the Department for Communities and Local Government. And so these guys helped shape the research, but also challenge us with a range of different policy questions. I think it's fair to say, though, that they don't take just the outputs from one project to inform and have a turnaround in policy, but absorb information from projects like this and a whole host of other sources of evidence. So it's not a case of we produce some numbers and then policy in London suddenly shifted overnight. This just added to their evidence basis. And so the first thing I want to just sort of talk about is actually one of the kind of the balances between climate change and socio-economic change in terms of mediating long-term flood risk. So here we have population in the Greater London Authority area, in the Black Ring, but also out into the Thames Gateway. And when you're thinking about flood risk in London, you have to think out to the sea, because that is one of the major drivers of risk in the city centre as well. And so by propagating a number of scenarios, and by this I mean infrastructure development scenarios, land use planning policies, through the land use transport model that Mike introduced, we can look at a number of different spatial configurations in London. Now, these are all quite extreme examples. These are not policy, they're not forecasts, they are almost caricatures, if you like, of possible land use, where we were looking at how different, really quite different and quite extremely different policies and drivers might mean in terms of risk. So up in the top left, we have a sort of a current trends, a baseline, where development follows along similar patterns to today. The Eastern Axis scenario is where we have assumed that investment in the Olympics and the Thames Gateway in general stimulates a very kind of Eastern-oriented growth. Decentralisation is where we focus development around the central business district. And the suburbanisation is where we try and grow the urban or the suburban kind of core towns. So we actually kind of grow elsewhere in London. And these are very different. They're not, as I said, they're not forecasts, but exploration of a range of different policies. And they have very different implications when translated into flood risk. So here, the red shades show the baseline, the kind of current flood risk in London. Darker red means higher risk. And the different bar graphs that you can see going from west to east on the north and south of the banks show for different spatial development strategies, we have different implications for flood risk. Unsurprisingly, perhaps, if you start building out in the east, where the flood defences are currently much lower, that has more serious implications for flood risk. But one of the questions that I often get asked is, well, that's very nice. What do we do about it? And so we kind of presented the same numbers, but in a slightly different way by unpicking these bars. And this is just for the Eastern Access scenario, where we can see what are the opportunities for dealing with risk and what can we not handle. So, for example, where we have dark blue wedges, and where they're largest, the greatest opportunity for managing this change in flood risk is from retrofitting existing properties. Where it's light blue, the greatest opportunity for managing future risk under this development scenario is by ensuring the codes or the design codes for future buildings are more resilient, can be more tolerable of being wet. And where it's light yellow, there's not very much that you can do about it because it's driven by changes in weather. So that, if you like, is growth that is outside perhaps of our development control, other than maybe by retreating from the floodplain entirely. But that's a different sort of policy problem. And so there you see, get a sort of a sense of how the socioeconomics and our policies, our planning policies and climate all have different degrees of impact, and indeed across London as well as just from the city as a whole. We also looked at a couple of other risks, and just one quick point here is on risks to water supply. It's the sort of the unseen risk, if you like. Quite often people in London see the Thames barrier, they see a whole load of large embankments, and they appreciate that there is this risk of flooding. But water resources is perhaps much more uncertain in the future. And here we looked at how changes in demand as a result of population growth might influence water security, and so going down is bad. Essentially, I won't go into the ins and outs of the metric here. But then if you add on changes, the forecast changes in weather, then it goes down a bit further. Or does it? Because there's huge uncertainty in the outputs of these climate models. It might go down further. In fact, it could not really influence these things at all. And so what we see here is that actually that if we don't manage our demand, then we will have increased water risks, if you like, water shortage risks. Climate change might throw in a whole other can of worms as well, but there's an awful lot of uncertainty around that. But what this graph here shows is that these kind of little wedges, I don't know if any of you have come across Socolo's wedges for global greenhouse gas mitigation, but this is a kind of equivalent on adaptation and how different measures, in this case fixing pipes, desalinating seawater, building new reservoirs, reducing demand, can kind of, if you like, turn around this risk from water shortage in the future. And all of these are relatively trivial in engineering terms, but if we were to do any one of them and achieve the same gains over 50 to 100 years, it would be a really quite substantial and probably unrealistic objective, both technically but also in terms of social acceptance of building anything on those sorts of scales. And so the compound benefits of a whole range of different options can help us achieve our goals much more successfully in this case. But of course, as I said, this was all about understanding some trade-offs as well, and now I've been talking about trade-offs between climate drivers and socio-economic drivers. But one of the things we looked at as well was greenhouse gas emissions and energy demands from some of these technologies. Very obvious one, desalination tends to require energy, and to achieve the same, if you like, benefits in terms of risk reduction from either building a giant reservoir or desalinating seawater, well, one, if you like, is a one-off construction cost as opposed to regular amounts of energy drawn to actually clean or desalinate the water. I've removed pumping costs from this calculation. So we can see that if you are obsessed with reducing greenhouse gas emissions, this might not be the best way to go forward, at least without changing the way in which you generate your energy first. And so another interesting trade-off was around land use and the urban heat island. Here is observations of actual kind of heat generation within the city. You can pick out the central business districts, and you can pick out Heathrow Airport there on the west. And working with the Met Office and their climate modelling systems, and I say this isn't quite the same as the global climate models, but just climatological modelling, they developed insights into how changes in land use, so perhaps associated in this case with increased densification and activity in accordance with the sort of centralisation scenario that I showed earlier, might aggravate and increase the urban heat island intensity. And so by integrating that, again, over with our understanding of heat risk, so the sorts of observed mortality or illness that are associated with extreme heat events, we can start to understand how this growth in development through our different land use policies might increase the risks associated with those heat islands. And indeed, if you add more energy to cool the buildings, you, of course, ramp up the amount of heat being produced as well. So perhaps having a kind of circular effect or an unwanted feedback. And just one of the final things, and I always get asked this, is why do people build in floodplains? Why do we do that? Why don't we just build off the floodplains? And this is quite an interesting graph. I mean, it looks very kind of simple. But what we show here is on the x-axis, the relative density of development compared to the existing development. So if you're in a very high density area of London already, then if you're building at the same density as is around you locally in that census district, then you're on 1. If it's twice as many people per square metre, then you're up to 2. Is that if we just allow the sort of London to develop with no constraints on land use, then we might be able to add another 5 or so million people at the kind of current density of development. If we double the density, then we can get more. But if we start to say, well, let's actually stop people developing in the floodplain, well, that immediately takes out space for about 1 million or so extra people. And if we try and get the people who already live out there, then we're again another couple of million back out. If we also start to say, let's stop, let's keep the green belt, or indeed let's preserve all our green space because it's very precious, then the actual amount of opportunity within London is really quite limited, particularly at the current density of development. And indeed, this black dotted line near the bottom at about 1.4 million or so is the kind of target for new population and housing in London. And indeed, if we were to kind of essentially constrain and rule out a whole load of space across London, we wouldn't be able to meet the Greater London Authority's target in this area. And so although it's quite simple, it's quite a powerful message from the point of view of that there are these trade-offs in terms of where we put people or allow people to develop rather than necessarily top-down control over where they go. But if we put too many constraints in, then we have this kind of lost opportunity, if you like. And that's why a lot of the time people end up in high-risk areas because they need to go somewhere. But these sorts of tough decisions are starting to become more common. And this is somewhere actually on the east coast of England, in North Norfolk, where the bottom stretch of that coastline, they allowed that to erode about 10 years ago, and you can see how far the cliff has eroded inland. Well, they've also now decided that the bit north of that is going to be allowed to erode as well, and you might notice that there are a few houses and properties there. So you can imagine what's going through some of those people's minds right now as the cliff gets closer and closer, and indeed some of those properties, since this picture is taken, have already fallen onto the beach. So, just to try and wrap this all up and perhaps tie it back into the sort of topic that we're discussing today, is that a result of this kind of work and others, specifically in the context of, if you like, reconfiguring cities to be more climate sensitive, we concluded a number of things. First of all, it requires some sort of motivation and leadership. Now, this doesn't have to be top-down leadership. Bottom-up leadership is also equally valid, if not more so. But still, it doesn't just happen, if you like, without it. But we also need to understand not just individual aspects related to land use, transport, resource flows, etc., but actually the interaction between them. And we need to recognise these different timescales of change. And of course, one of the big problems is the legacy of past decisions that we're dealing with, and the inertia behind those decisions taken. Well, I mean, as Mike was talking about, the sort of the road layout still being not dissimilar from 1666 in large parts of London, and what that has constrained us in today. But perhaps one of the most important lessons we felt that came out of this was that this kind of collective understanding of these different functions, in the case of climate here, and trying to bring together the relevant stakeholders and who had some role to play in terms of informing key decisions, was crucial to actually allowing people to understand where we're all coming from and leading to longer-term change. And this sort of cyclical approach of understanding, monitoring, bringing together knowledge through these integrated assessment systems, and working with individuals, organisations and so on to think through the implications of their own decisions on others and the decisions by others on themselves before actually intervening and trying to deliver something that achieves some sort of common sustainability vision. So this slide then is perhaps an attempt at trying to answer, because is this kind of integrated assessment information useful? Mike mentioned that we had a lot of dealings in particular with the climate change and water strategy manager at the Greater London Authority, Alex Nixon, and he very kindly suggested that it was. As I said before, this kind of work didn't lead to some round, U-turn in policy or big change. It was a part of the evidence basis that he uses to inform his decisions, which have to include this, but he has to take into account a whole host of other issues as well. Ultimately, it seems unlikely that no single research project is ever going to do that. But just one kind of final thing, and these are perhaps some open questions that I think remain in terms of using these sorts of integrated assessments for improving the urban experiences. One is related to tracking down these sort of interactions and how far you go down in terms of the detail of the modelling. How do you deal with uncertainties and communicate those? Are these sorts of things transferable? Well, we're having a go at that right now, not just in the UK, but internationally as well with some of our work. And how can we actually use this sort of complex information? Because it's not just a case of, your car is round the corner and will be here in 5 minutes to pick you up. There's potential for real information overload when you're trying to deal with a whole host of different sectors, potentially simultaneously. And point 5, I think, is really perhaps being addressed right now in terms of getting people from a whole range of different backgrounds together thinking about some of these issues. So those are some questions back to you, but please feel free to throw some straight back at me right now, or indeed later today or tomorrow. But thanks very much.
Yes, I see 2 or 3 on this side. Ed?
My question is this. You mentioned briefly, both on this last slide and earlier, about uncertainties and the uncertainties, the final answers you get, for instance, and acknowledging the fact that when you have a complex model system, or a system of models, that uncertainty naturally becomes more complex because it's accruable to many different models within that system. My question was, I assume you've actually quantified uncertainty in some of these predictions, and B, in quantifying that, did you actually take into account the uncertainties accruable from each of those different systems, the land use transport model system, the hydrological system, and so on? And C, do you have any insights about how pulling these together either makes it more uncertain or less uncertain? Do they work together? Will they work against each other, and so on?
Okay. We estimated as many uncertainties as we could. So that's our answer to A, I think. Not all, I don't think it's ever really possible to get all in there, but as many as we could, and as many as we felt comfortable quantifying. There are always, if you like, the unquantifiable uncertainties. I'm sure Donald Rumsfeld said something about that along the ways. In other cases, we perhaps took out an attempt at quantifying the uncertainties by, for example, those 4 very different spatial development scenarios capture, if you like, or boil down a whole host of uncertainties, because they're not so much forecasts or some, but actually just explorations of a very big uncertainty space. So there we're acknowledging that the space is enormous. We've pulled out 4 trajectories that we think are different. So we're trying to be as honest as we can about uncertainties. And in terms of the kind of the interaction, mainly they make it worse. So mainly you don't get them cancelling each other out, unfortunately. Which is part of the reason why we use scenarios where we felt it was the uncertainties were almost intractable if you were looking that far ahead. You know, most land use transport modelers wouldn't go past 10 or 20 years. You know, going sort of 80, 90 years into the future is just not, it's not kind of forecasting. You know, it is scenario exploration. So we've tried to be honest about those, but that kind of allows us then to quantify some of the other uncertainties, like those associated with the climate change forecasts. Again, all of those are not well quantified, but it allows us to kind of at least be honest about where they're coming from. But they usually stack up. Is that all ABC? Great.
You showed a temperature map of the city, and there was about 1 degree difference between the city and sort of, as I recall.
Just to clarify, that was the increase in the urban heat island intensity as a result of land use change. So that was not the urban heat island observation, it was the additional increase as a result of new land use. Yeah.
Is it more in winter or summer? I mean, from my experience, for example, there could be 4 different reasons for that. Either heat insulation is poor in buildings in winter, or maybe air conditioning in summer, or car use, or wind speed.
Right, that was nothing to do with inside buildings. That was all outside. So this was all the kind of the external environment. Obviously, once you're inside a building, then there's a whole host of technology in between you and the outside world. So that's a kind of an added layer of complexity on top. So I think that map I had was for summer. That was showing the summer change. In winter, it can often be a bit larger. But basically, the urban heat island intensity is measuring the difference between the temperature at that point, usually in the city centre, and some rural station. And so what you're seeing there is that there's well, for a whole host of reasons, but often the heat inertia of the buildings absorbs a lot of the heat during the day and gradually releases it back at night, is one of the observations that you see. And well, as I said as well, the actual energy of activity, transport, air conditioning units spewing out hot air to cool down buildings, so on, they all add to the local temperature factor.
Richard, how did you come up with those numbers for the risk proportion by borough, what you added to that map? Or that maybe
Sorry,
they weren't numbers.
are we talking about the pie charts?
Yep.
Right. Well, that was disaggregating the bar charts by where the contribution of the risk came from. So if we have, if you like, today's risk, and then exploring, trying to keep exploring the amount by which that might be reducible if we were to retrofit today's buildings. So that is, for example, how you could evaluate the effectiveness of retrofitting existing technologies. Then if we're looking into the future, it becomes a little bit more complex because you have to then unpick the contribution of additional risk from what's there, if you like, today, as well as what's there in the future. It's probably a lot easier to actually just draw it on a whiteboard or something. But essentially, it's trying to decompose the overall change in risk that we see without according to where it's coming from.
Mm-hmm. And did you lay any of this over issues related to sort of equity?
Yes, but not in what I'd call a kind of robust way. So there are there's data on each of the sort of the census districts showing someone else's index of deprivation. In fact, for every single census district in certainly in England and Wales, if not the whole UK. And you can have a look over that. And yes, you do often find that the more vulnerable are located in floodplains. That's not just a feature in London, actually. It tends to be observed around the UK, if not the world.
Very good. Is it a quick question?
Yeah, sure.
Yeah.
It's just a quick follow-up on that. Just to say that Joseph Rowntree Foundation are doing a lot of work around equity and flooding, especially looking around the ooze flowing through York. And the key thing that comes up is not only is it the poor and the vulnerable that get flooded, but of course it's a vicious circle because they can never get insurance. And what really you need to start looking at is the prediction of the insurers about who and what gets insured against flood.
Which goes back to your point when you keep getting asked, why do people live in floodplains? It's part of the answer.
Yeah.
In fact, I was going to ask you too whether you've got people like Willis Re or Swiss Re involved in this study, because they do very detailed analyses of their own. They're not probably quite so concerned about equity, but perhaps you could introduce that.
No, well, they weren't specifically involved in this London work, but we are now on the Willis Reinsurance International Research Network. So they're kind of now aware of this work anyway. What they do with it, I don't know. They haven't offered to fund us to do more of it yet, unfortunately.
There's a gentleman I know at Swiss Re, David Bresch, who was the editor of a World Economic Forum document on natural disaster impact, I think, earlier this year. And I can send you a link to it, I think. And one of the conclusions there is that there are certainly regions of the world that will become uninsurable in the next 50 years.
Yep. I'm not surprised to hear that.
All right. I'm not sure whether to give you a round of applause, but